So I'm Andy, and wanted to introduce a topic that I think it's not often discussed in the Ethereum ecosystem, and it is extremely important. And as you might have noticed from the side and the introduction, it's related to privacy and how we are under-protected and we don't even notice. So let me start with a letter that someone wrote to you guys. Dear valuable user, thank you for your 847 queries that you did this month. We really enjoyed getting to know you. We know that you hold ETH across 3 different wallets. We know that you checked the price of ETH 94 times last Tuesday. It was a very rough day for everyone, so no judgment. You also checked the price of BTC price, but it's interesting because you don't hold any Bitcoin. Are you thinking of diversifying? That will be between us and, of course, our analytic partners. You're also watching 2 Uniswap pools very closely, and you checked your Aave health factor 14 times last week. You might want to relax or just add some collateral. On Thursday, you also checked it 3 times within 12 minutes, and you were very worried. You looked at 4 different ENS names, or either you're starting a new project or you might have an identity crisis. And you always go quiet between 11 p.m. and 7 a.m. Mountain Time, so we're fairly confident that you're based in Boulder or close. You never signed a single transaction through us. You never had to. Your curiosity told us everything. Warmly, your RPC provider. So of course, this is a fictitious letter, but something that we do leak every day. Even if you're not doing any single transaction, any action on-chain, you're basically telling everything that any analytics and company would love to get their hands on that data and your behaviors. So what is really going on right now? In the privacy world, I see that we put a lot of emphasis on-chain privacy, or what we in PSC called private rights, like all the actions that you do on-chain. And it makes sense, right? Those actions get recorded forever. It gets transmitted around the world. So it does make sense to not leak your address with a specific action. And we do put a lot of emphasis on tooling as well, right? Like your data sources, your, proofs and DSLs and languages that we can use to give more tools to developers and express and build stronger apps that have more privacy on-chain. But I want to argue in this presentation that we don't put nearly enough attention and effort into these other domains, which is what we call private reads, which is whenever you query data from a blockchain, you're leaking a lot of information, and private networking, even before anything arrives on-chain. All the traffic, all the things that you do, you're leaking. And to get a little bit slightly more technical, right? Like all the RPC calls like eth-get balance, eth-call, and eth-get logs, all of those things are requests on the plain text that go to RPC providers that get related with your IP. And with this information, it becomes very easily to profile people, to segregate, and to create behaviors. And this can be used against you. As you would imagine, information is power, and the more information people have about you and your behavior, the more power they have on you. And most people don't realize, and most people will say like, okay, well, it doesn't really matter because this is not like critical information, or it could also think like, the more activity there is, the more protected I will be, which this is entirely not true and counterintuitive. In on-chain actions or whenever there's anonymity sets, it does help that the more users, the more privacy there is, the harder like you blend into people. But with these things, because things are more, they're not interchangeable, the more activity you transmit, the more things and actions you do, the richer the correlation surface and the easier it is to create a profile about your actions. So whenever there's like DeFi mania, like, NFT craziness and all of these things, people become more sloppy. OPSEC, of course, gets thrown out of the window, and it's much easier to de-anonymize people based on these activity patterns, behaviors that most people just fall into. So I want to start high level, well, some technical aspects about how is this landscape and where should we attack it? What's needed? Who's working on what? This is a talk that I'll try to go some topics like more technical and some topics more high level conceptual, so you can take some value out of this for everyone. So I want to present this, which is what I call like the Ethereum Privacy Stack, or the layers of the Ethereum Privacy Stack. And I think this is useful to reason about if we really, really want privacy, we don't only need privacy on-chain, but we also need privacy in all these layers of the stack. Similar, as you can see, like, I don't know, the life cycle of a transaction, the OZ model, and all these, technology layers. I argue we could create a standard or some sort of like ecosystem-wide acknowledging that there are some layers. Maybe this is not the final form, but I think this is arguably already useful. So the top is the application layer. So whenever you visit a website, of course, you're leaking what you're visiting, right? And people can start profiling anonymity sets, credentials. They can start linking to your IP where you're visiting, even if you don't even, do anything, right? The next one is the wallet layer. Whenever you do any action, you don't only leak information to the app layer, but also to the gateways whenever you do an action at the wallet level. And wallets right now are very complex, and they integrate with so many other systems and services, and you leak a lot more information than what you imagine. Even if you just like open your wallet and query the price of ETH, or open your wallet to see your balance, you're leaking everything. Then you see gateways, the RPCs, the proxies, the relayers. You leak, again, more metadata. Then what people would imagine as the on-chain element, which is whenever things are queried either on the EVM, like the state, or the execution patterns. So, for example, query the balance of something, or if you want to see the state of a smart contract, this is the layer. And finally, the consensus, where it's like all the validators. Depending if you're writing things on-chain or if you're reading on-chain, you might also touch the mempool, of course. So this is just some examples. And there's like another vertical, which is what we call networking, which is transversal or like cross-layer, like cross-cutting, all these layers, right? So for example, right now you visit a website and the server knows your IP. But what if you visited that website through Tor or any other, onion network? You would know the IP address of the website, but they wouldn't know yours. But what if that IP is hosted in a country where recently, started censoring all crypto things? Probably that website and that company would also want to hide their IP and would also want to hide their domain behind like a .onion domain, So those are the type of things that it does make sense, right? We need to go layer by layer, hardening everything, analyzing through the eyes and lenses of like a very disruptive attacker who wants to censor everything. And this is the type of things that even if we don't do it and we say like, oh, we live in a good enough state, this information gets recorded now, and forever it will be hosted by a lot of people that you don't even know, right? A lot of companies that just start selling your data. And eventually in 5 years, somebody might ban like crypto and will say like, oh, anybody who used Uniswap in the last 5 years, I'm the IRS, I'm gonna, start knocking and like get you to jail or whatever, right? Like these dystopian scenarios, which happen in the world right now in different countries around the world. So this is, okay, Ethereum Privacy Stack, where should we focus? In this presentation, I want to talk about these two areas, right? Like the private reads, which is like whenever you access state from on-chain, you touch all these layers, right? From the app, let's say I want to query the price of ETH from the app to the wallet, to the gateways, to basically a node that is running Ethereum, the EVM, and then back from the database, and basically it's a RPC provider or like indexer or something, and then the private networking, which is all the actions that happen, on the networking layer, and this is what we want to harden. So there's 3 pillars that I think they are critical for us to achieve this. We want to hide and make private the data itself. We want to hide and make private the traffic itself. And then we want to make it very performant and useful and practical and cheap and on all of these elements. And these are all, this is summarizing a lot of like information and things that are going on in the ecosystem. But I think it's useful to kind of like, paint the lay of the land and what are the most, the leverage points that we can do to accelerate. So data, what is it that we want to protect? We want to hide what information you're asking from these servers. We want to hide the patterns that you do through accessing this data. So it's not only the content, but also the patterns that you do. And there are different techniques, like, the principal technique is, there's nothing, right? You just leak everything. You leak, like, whenever you connect your wallet, you tie your IP address with a contract that you're querying, with a specific ETH address, and that's it, right? even if you're in a privacy protocol, let's say in Tornado Cash, and you want to query the state of the Merkle tree, and if you leak what is the path that you're querying, the leaves, you either have to download the whole tree, which is like not very performant, or you leak your path, reducing your anonymity set. So again, even just using a very privacy protocol like Tornado Cash is not enough if you don't protect your networking and your access patterns from data. So one is like no protection. The other one is, okay, some sort of like proxy relays. You know, you have a lot of machines that just like, they don't know where the request comes from and they just eventually retrieve that. That's not very, it's not very practical and not very trustless. Then you got TEEs, which is a step forward. And this is where I think some teams are offering these services to companies, and I think this is a good step forward, but not enough. Again, because of the cost of attacking TEs is dropping a lot and corrupting, and perhaps for certain critical use cases, this is not enough. For many others, day-to-day, it could be enough. There's other teams talking about OMAP, Oblivious Map Access Patterns, and ORAM. Can't remember what it stands, but these are just like similar techniques where it tries to obfuscate what parts of the data set you're trying to access. So instead of saying I want to access the balance from this ETH address until this ETH address, the server doesn't know. You're just like randomly accessing different things. And I would argue one of the most the end game of these will be PIR, which I will go into more details, but it just means private information retrieval, which means the server doesn't know what you're querying and doesn't learn anything about it. Okay, so private information retrieval is like a super powerful technique in cryptography, and it's going to be used a lot. There's just two variances, like index PIR, where if you have like structured data and they're indexed, if it's indexed, you can use those schemes, or keyword PIR, which, yeah, as the name tells, like you query per keyword. It's very hard to have one scheme that works for everything. Ethereum state is huge. It's very different. Like logs, yesterday I was learning that it's just like append only, but the account model is different. Some gets updated very frequently, some don't. And some can be, depending on how you slice and dice, you can have megabytes of data, terabytes of data, gigabytes of data. So, and very different like patterns of like numbers and ASCII, etc. So the proposal that we're working within PSE, and this is I'm gonna be like talking conceptually and then talking about specific projects that we're doing at PSE and other things that I'm seeing in the ecosystem. Okay. By the way, this is a 35 minutes presentation, so if there are questions, I'm super open to kind of like just answer them. I know it's not the format perhaps that other speakers, but like I'm super open because otherwise it could be a bit boring and dry. Okay, so PIR. The architecture that we're proposing is like a multi-agent architecture. There's no single scheme that is perfect for all Ethereum states, but if we can slice this Ethereum state per type or for access patterns, etc., we could find very good schemes for each of them. So what if we have a service, a company that just run this multi-agent architecture, and then depending on the type of queries and where they might be located on the Ethereum state, they will run one scheme or another. And it's already get us very, very closely to something that is feasible in production and capable to offer to the ecosystem. This will require something called like a unified API. So like the wallets, the indexers, the users, the app developers don't need to worry about what is the scheme and how you call it. You just like have the standard API and you just have someone else worried about the implementation details. And we're already doing this and implementing 2 different schemes. We will open for grants, and we're trying to coordinate more people on the ecosystem to tackle some of these and see which ones are the most needed for Ethereum. This is just a few numbers about different PIR schemes and some throughputs, communication overhead, etc. And even like it's hard because different apps have different access patterns, right? Some access a lot of receipts, like Aave, right? Some want to access more the state, like Rotkey. Some access more transactions, like Helios, et cetera, right? So just want to say like there's no silver bullet, and most likely like something mixed architecture will be helpful. We're also doing a systematization of knowledge. So if this is interesting to you, we can share this. And this is just some teams. And forgive me if you are a part of a team, or if somebody sees the recording and I didn't include you, just please let me know, and I can start adding and start talking about these things, working on these areas. The other one, so we said data, right? The other big bucket is traffic. So how do we hide traffic? What do we want to hide? In very simple terms, we want to hide the client and the server's IPs from each other and from the rest of the world that might be snooping traffic. And we have different techniques. We have onion services, we got mixnets, we got VPNs, we got DC nets, and there might be other classifications. I'm just going to talk about the first two. So onionization, like Tor, basically, how do you call this? Frontier, these like type of techniques, which kind of like encrypts in layers, and then it gets decrypted in layers as well. So like people in between can never know the origin. Some people will never know the destination, and some people will never learn anything. They just like act as like router patterns. So in TLDR is like, what if all the Ethereum ecosystem and traffic, we could route it through the Tor network? To say Tor, but there are other options, right? We would help protect the sender IP. Like we would not be leaking your phone, your laptop, your whatever you're sending, or sending transactions or requesting information. And of course, the receiver, the server, we would also protect it. So let's imagine if in, I don't know, Iran, China, North Korea, or like Venezuela, whatever, somebody's trying to host a DeFi protocol or a service, and it's censored by their country. This is an option, right? That will protect their lives and will open to, just a good pattern. So bypass censorship, also hide from ISP, internet service providers. Like we all know that these are tapped by intelligence agencies and they're just like snooping everything. So this helps. And the goal is to have a drop-in replacement. So an SDK, the wallets and dApp developers and infrastructure providers don't need to worry about the implementation details. They just know that if they use this SDK, the traffic gets onionized or encrypted, and it's hard. So there's a team, and shout out for the Broom Wallet team who started like Echelot, which is like open source JavaScript implementation, because this exists right now. Like exists like Tor clients, but on C, and they just run on your, on your browser. You need a special browser. But what if I want to add this to MetaMask, right? Or to Kohaku Wallet, or to Amber, to all these other Rabbit, etc. We need like JavaScript SDKs and WASM. So like started Echelot. Then we the Tor project has a new implementation being developed called RT. Like it's the next generation of their client. But we need an embedded RT, so something that RT can be compiled. It's Rust-based, but it needs to be compiled WASM and to be able to run on your browser, so you can just import it really, really easily. So we're having basically collaborations with Tor team every week, calls, and some like projects and partnerships together. And then on the Mixnet side, I want to give a shout out to several teams. I'm going to get ahead just one slide. Several teams that are approaching through this, like the NIM team, Hopper, also one of the first ones. Well, there's VPNs like Gnosis. There's two others that I didn't know before at any one protocol, and I think somebody of that team should be here in Denver, and ZK-net, some other new ones. So there's like many teams working on these like Mixnet VPNs, like other approaches, and we want to see what if we create a purposely designed Mixnet for Ethereum that we can try at RPC traffic. Because with mixnets, they have strong guarantees, but they add a lot of latency. So for some use cases, it's all fine, right? Like it doesn't matter if it takes a little bit longer as long as you have privacy. But some things like DeFi and trading and others, it's extremely unlikely that these will get adopted if it has latency. So what's the fastest that we can run with the highest privacy guarantees? Yeah, shout out to some of these teams. Again, if there's someone from working on these areas and I haven't added you to this, I would love to chat. And the last thing I want to chat, or like the third pillar to make this reality happen, is performance. So we want these things to run fast, to run cheap. I have an idea, like a principle, which is like these things won't get adopted if the cost is higher than the benefit. And the cost mean the cost for the user experience, time, effort, but also cost for the developers and for the infrastructure. Is this very expensive to run, etc.? So we need to lower the cost as much as we can. And there's two initiatives, high level, that I can talk to. One is UBT, and depending on how much you are involved in the like protocol EIPs, you might have heard of this. Right now we have Merkle Patricia tree, which is like useful but not very useful for CK and other cryptography type of stuff. And there is a proposal, EIP 7864, which is moving not to Merkle trees, but to unified binary trees. And this is much, much efficient for querying state and then doing operations on cryptography like CK. So we have a project that it's verifiable UBT, which is basically you add a sidecar to a specific, to any like Ethereum client, which instead of running an MPT database, it has like a UBT state database. And then you prove that this transformation from MPT to UBT, it's valid using a CKVM. So this is already very powerful. And once we manage to do this, things like light clients could use this to increase their performance, and things like PIR could run much faster. So we have a project doing this. And the other aspect is GPU acceleration. We can run these things much faster if we optimize lower levels of the stack. GPU is one, or CPU accelerations as well. But these things will probably run on servers, not on phones. So it's also like very valuable to start exploring how can we just create these lower level libraries to run way faster. So okay, doing a recap so far, right? This is like, what is it, like part 2. We got 3 pillars. Let me just, I like doing recaps now that I have time. We have these 5 layers. We want to cover these use cases right now in this presentation, and there are 3 pillars: data, traffic, and performance, right? Data, we have proxies, TEs, ORAMs, OMAPs, and PIR. Traffic, we got Mixnets, Onions, and others. And performance, we got UBT and GPU. And if you want to read more about at least the contributions that PSC is doing, you can go psc.dev/projects/research. So what is success? How can we measure it? Coming back to these layers. If I want to say like Ethereum is the most private, if I want to be able to claim that Ethereum is the most private chain and what is the end game, I will say like I will need to feel comfortable with all of these layers extremely hardened. Right? So like, how would I measure it? I would expect more websites and like dApps front ends to be hosted behind like .onion domains. I would love to like wallets to natively use like anon routing and gateways as well, and RPC pattern, RPC providers and indexers, and et cetera. And I would love like, I would just measure a percentage. So the question is like, from the current Ethereum ecosystem front ends, how many of them are hosted behind like Tor, .onion domain? I will say like extremely few, right? Like 1% if any, right? And I would love for things to, for me to feel good and say like, yeah, we did it. Like we would probably need more than 80% at all of these layers. Like how many wallets right now are routing traffic through these, anon routing techniques? Very few. Like very, very, very few. And the same way with RPC providers, do they offer a PIR offering, these providers? No, right? So for me to claim success is for all of these layers and the actors that are on these layers to be adopting these type of technologies, and at least 80% of or the teams or the traffic or the queries adopt these type of technologies. This is one thing that we can be jealous of Bitcoin, right? Like for all the critiques that they have. This is a picture when in November of last year that 64% of their nodes, of the full nodes, are hidden behind onion domains. Can we do it ourselves, right? Can we say, this is like lower level, consensus level privacy, but like, could we say that our nodes, like full nodes, validator nodes, are behind onion network or mixnets? We should. I definitely think we should, and we are probably less than 1%, and we have other challenges that they don't have. We run much faster. There's consensus is different. I would love to have dashboards like this and say like, I don't know, more than 80% of the wallets have adopted these type of technologies, and more than RPC providers and explorers and front ends and load balancers and SDKs. Like I would love for this list to grow. And I took the liberty of like last night and the night before, just like starting seeing how, through these lenses of layers, how do we compare, like the Ethereum ecosystem compares to things like Solana and Bitcoin and Zcash and Monero. And things in yellow are things that are opt-in techniques. So I think we're very good. Things in blue, there are proposals, and some of them are protocol proposals. Things in green are like things that are enforced at the protocol layer. So because of our 10-year history of like being a public chain, I think it's going to be hard to catch up with things like Monero and Zcash to be, add this like natively. But I think we can do a really, really good job at getting opt-in and culturally, socially, influence the teams, the users to adopt more of these techniques. And things like, Bitcoin and Solana they have their own challenges, and I think they'll be further behind, at least on these private things. So my goal, and the goal that I want to put in your mind, is for Ethereum to become the most private, permissionless, trustless, and programmable ecosystem in the world. We got some other payment private chains, and that's great, and they're like very good, but I think they will have a much harder job at becoming programmable and creating the ecosystem that we have created. My challenge to you guys, and of course to me and my team, is to become the most, from the programmable ecosystems, the most permissionless, trustless, and private. And we can only focus on the on-chain elements. We need to focus on all of these layers, right? So if you're working in private reads, networking, PIR implementations, GPU acceleration, data structures, UBT networking, infrastructure providers from here, validator, I would love to chat with you afterwards. And yeah, thank you very much. Ethereum is for privacy.